Hi everyone, and you are welcome to OOP Basics Conclusion. First of all, let me tell you that you have done super great job so far, and now you have all the basics that you need to create classes in Python. In this lecture, I would like to review with you all the important concepts that have been covered quickly in this section. This section has been started by talking about what OOP is, and we see OOP is just a programming style in which developers are able to create new data types by binding together two things. These two things are data properties, and we call them attributes, and these are the data fields that describe the new type. Also, we combine with these properties functions or methods that usually process these attributes. In context of OOP, we see that the new data type that's created, we call it a class. The data fields, we call them attributes, and the functions that process these attributes, we call them methods. We see an example about this bank account, and we see that we have some attributes like account holder name, account ID, balance, and for these attributes, I can process them by the methods withdraw and deposit. And we say, when I have a new class, or in other words, a new blueprint or prototype, I will be able to create as many as objects I want from this class. So let's say from this bank account, I will define an instance or an object, its name account1, and I have to specify real values for the attributes of that object, like John Smith, etc., etc. And once I have a real instance from my class, I can use the methods of that class to handle and process the attributes of the object. After that, we have learned about attributes and methods. So let me start by talking about attributes types that we have seen in this section. We have seen two types of attributes, instance attributes and class attributes. If I want to compare between them now, we say that instance attributes belong to the class instances, objects, whereas class attributes belong to the class itself. So, instance attributes for the object, class attributes for the class itself. Now, each class instance has its own value for these attributes, which means these attributes are not common or are not shared between the class objects. Whereas class attributes are shared between all the class objects. And if one object tries to update the value of this attribute, it will be changed for all of the other attributes. Okay, now let's summarize what we have learned about methods so far. Actually, we have seen that we have three types of methods. We have instance method, class method, and static method. First of all, we have to know that in instance method, the first parameter is self, and this parameter represents the object that's calling this method, and this object, which is self, is automatically be passed as the first argument in the method. Whereas in class method, the first parameter is CLS, which is a reference to the class, and this is also automatically be passed as the first parameter. Whereas static method doesn't have access neither to the object nor to the class. And usually they just behave like a regular function. Now, in order to define an instance method, we don't use any decorator, where in case of class method we use @classMethod decorator, and for static method we are using @staticMethod decorator. The last point that I want to highlight that we are using instance method to handle and process the instance state, or in other words, the instance attributes, whereas class method usually are be used in order to handle and modify the class state, or in other words, class attributes. And usually in static method, we don't modify nor class, neither object state. After that, we have learned about a property, and we have seen that sometimes we need a way to do kind of pre-processing when I want to get, set, or delete an attribute. And in order to do that, we define a property. And to define a property, we use a property function, which is a built-in function that creates and returns a property object. And as I mentioned, property, we are using to add any kind of logic when we want to set or get or delete an attribute value. And keep in mind also, there is another way to define a property, which is property decorator. After we have had all the knowledge that we need in order to create a complete class in Python, we have defined the first two pillars of object-oriented programming, which are abstraction and encapsulation. The first pillar, which is encapsulation, is all about combining the attributes and the methods that handles all of these attributes under one umbrella, which is the class. And encapsulation is a very important pillar of OOP because of this concept, we are able to easily maintain our code. After that, the second pillar, which is abstraction, has been defined, and it's a very simple pillar, and it's all about hiding away the implementation details from the external user. And OOP satisfies this concept because usually we expose to the external user the methods that he or she should use in order to use the main or the core functionality of the class itself. And this pillar make the code written in OOP style easy to be shared with the other because they will not be aware to the complex details of that class. The last concept that has been covered in this section is copy in OOP. So, we say that if I assign one object to another, actually I'm not creating a standalone object. What I'm creating is just a shallow copy of this object, and in other words, it's just a reference to the same location in the memory. So be careful, because if you update one, the other will be changed. And if you want to create a standalone copy, you have to create what we call a deep copy, in which we use the module copy, the function deep copy to create a deep copy. And in this case, you will have a standalone copy of your object, and if you change one, the other will not be affected. The last idea that has been covered here, it's identity operator, and this is just a simple operator usually we use in order to know if one object is a shallow copy of another or if it's a deep copy. Finally, if you want to review all the code syntax that has been covered in this lecture, please refer to the file OOP Basics Syntax Appendix, in which you will find all the syntax that has been covered, summarized, and well organized. That's all for this section. Thank you very much for your time, and if you are available, join me in the next section.